All right. We are going to start. This is a lesson over radicals, or specifically. It's always interesting to see how different schools do different things. So Goshen, when we did this, radicals, also a few groups, the pattern to do any of those. I honestly don't know if we'll get into that later, but it's not going to be this lesson. Like I said before, this lesson was actually mixed into the imaginary lesson, which is fine. It's just that's kind of a lot in one big lesson. There's a lot of concepts. Timing-wise, you probably get it done, but just a lot of concepts. Hopefully, the idea is that you guys have done this before. I guess I should say, hopefully you've done this before, and I'll go on. Hopefully you remember how to do it. That'd be great. However, I'm assuming that you've seen this before. So if you kind of remember this for Algebra 1, perfect. You're sitting pretty good. If you haven't, don't worry about it. I'm, again, kind of starting this from scratch. So the first thing I want to go over is, so when we have the square root of 25, square root of 144, the answer to plus or minus 5. So why is it different? What's about a plus or minus? The reason is because, and I tried to say it this way when we did the last chapter when we had problems like this. Squared, so let's take the square root of both sides. It's got to be plus or minus 5. But if it just says the square root of 20 for an x squared, you do not have to worry about the plus or minus. So if that's confusing, here's a good way to remember it. This chapter, you do not need the plus or minus. Say this left chapter somewhere, but I don't think so. I don't that plus or minus. Again, come back and bite me in the butt, but as far as right now, that's what we'll go with. So the square root of 144, the square root of 400 is just 20. There's no plus or minus. You don't have to worry about that. Really nice, where those worked out to be really nice whole numbers, decimals or fractions. But we're going to do problems today where they aren't going to be whole numbers, but we're going to do a different notation rather than doing decimals or fractions. And it's called reducing radicals, or simplifying a radical, or simplifying a square root. So a couple things before we start. First thing is, you can do this in your calculator. So you need to show your work. The Casio calculators that I have, a lot of you guys have the same Casios. I don't know how many TI calculators do it, but if you just type it in your calculator and hit enter, it'll give you the answer for every single one of these. So I need to say that because I need to tell you, if you do that on a test, I will count every single one of them wrong. You need to show your work. It's not a lot of work. It's only one step. There's only one thing I need to see. I'll show you that, but I need to see that. Bothers you, and if you're really upset by that, I could just do it how the other teacher does it, where she doesn't let you use calculators on this test. She'll give you the 4-function calculator, add, subtract, multiply, divide. That's all that's on there, and that's what you have to use. So I'm doing you a favor by still letting you use your calculator, and the best reason I'm doing that, or the best way that helps you, because I have to do it anyways. I did that on the answer key to this. I did this when I made these notes. On everything I put in my calculator to check, because all you do is type it in. So you need to make sure you show me your work, and since you use a calculator, you can check your work. That's the big things. So before we get started with this, I want to make sure you're familiar with this list. And I'll probably actually make this a little bit bigger. So this is, if you have your x, so this is just 1 through, I think I went up to 15. This is your x squared. So 1 squared is 1, 2 squared is 4. I will probably add an extra column of x to the third for another lesson we're going to do next week. But I will give you that on a test. Now, I didn't finish this. I stopped at 10. So make sure you go through and finish this. And the reason I stopped at 10 is because I want to make sure you understand the concept. 11 squared is 121. 12 squared is 144. If you think I'm going too fast, I'm just doing it. I'm just squaring those. You can use your calculator. I've always had that where it seems like I've had that before in the past where someone says, you're going too fast. Yeah, it's because I'm not trying to teach you this. It's something you should know or know how to find. 13 squared is 169. 14 is 196. 15 is 225. Now, the reason I do that, 100% honestly, the only reason I make you do that is because I've had people that when I make this list for them, they don't think that it goes on and on. I give them something that's like 17 squares, plus other stuff, and I don't know how to do this. No, this keeps going. That's why I have it set over here. And a math joke at center squares a little fun. Not really at all, but that's okay. Try. This keeps going. 16 squared, 17 squared. So if you ever have a problem that's bigger than this chart, just fill in some more of that chart. Just do 16 squared, 17 squared. I mean, it might take 30 seconds to do, but it's not hard at all. And that's kind of my goal with this lesson, is to make it so it's not that hard. It just might take some time because you're typing in a lot in your calculator. That's the goal. Okay, so now I have that taken care of. And again, we might have to add to that a little bit later. So these are the 3 steps to solving this, and I might reword this a little bit later for next year. The whole idea, we want 2 numbers that multiply. Okay, so if we have the square root of 24, that 24 is the inside number. It's called the radical. You will not need to know that because it's worthless information. 2 numbers that multiply to 24, well, we're going to pick those 2 numbers strategically, where one of the numbers is a perfect square. So in other words, one of the numbers, I need 2 numbers that multiply to 24, but one of them have to be from this list over here, the list of perfect squares. So look at this, 2 and 12. Well, 2 and 12 doesn't work because 2 is not on our list, and 12 is not on the list. And again, we're only talking about the right-hand side of the list, because the right-hand side is the perfect squares. So we can't use 2 and 12. So if you look at this and you just can guess what it is, good for you, that's awesome. I'm going to discourage that, because sometimes you take 4 and it works really well, and other times you take 4 and there's actually a bigger one you can take. So I picked a small, 24 is a small number. I picked that one to show you guys, just to get you guys in the rhythm. If it doesn't make sense, once you see the rest of them, I think it'll start to click. This works because you do it the same way every time. Again, I know some of them, it takes longer to do it this way. There is a couple shortcuts you could do, but I got to the point where all the shortcuts kind of got more confusing, and so now it's like, I'm just going to cut all the short stuff, and we're just going to do the problem where it might take a little bit longer, but it's going to be a lot easier. Numbers of all 5 being inside number, one has to be from our list. So the way we're going to find that is we're going to, and we want the biggest number from our list. That's important. When we get the biggest number, is we're going to find where 24 would be on our list. So start on our list where the radicand would be. The radicand again is at 24. So what I mean by that is 24, if it was on our list, 24 would be right here between 16 and 25. Make a mark there. Eventually, you might not want to, so you don't just erase light, so you can erase it. But 24 is in between 16 and 25. Obviously, 2 numbers that multiply to 24, they can't be bigger than 24. That doesn't make sense. So right there, that's the one. I'm going to do trial and error. And again, some of you guys know what it is already. That's fine. But again, we're going to get to some where that's not going to help you very much, or it can hurt you. So 24, we're going to start there, and we're going to do trial and error and find which one of these is a factor. So do 24, and when you find 24 divided by 16, see if that gives you a decimal. 4 by 9, see if that gives you a decimal. So 24 divided by 16 is a decimal, so that's not going to be it. 24 divided by 9 is a decimal. That's not going to be it. 24 divided by 4 is 6. That's not a decimal, so that's what we're looking for. So we have 2 numbers that multiply to be 24. One of them is from our list, 4 and 6. I personally always put the list. I always put that first. Now here's the catch. 4 times 6 is 24. We do want 24, but actually we want the square root of 24. So it's not the square root of 6. It is the square root of 4 and the square root of 6. So this is the whole point of this problem. The whole point of this, the reason I picked a number from our list, the reason I picked 4, that is a perfect square, is because now I can actually take the square root of 4. The square root of 4 is 2. So that reduces 2. And you cannot reduce the square root of 6 at all. So that just stays the square root of 6. Your answer. However, make sure you hear me when I say this, because I will not feel bad. I will sleep soundly possibly with a smile on my face because I'm a terrible person. If you do not put this step right here, I'm counting you wrong. The square root of 6, I need, because again, I'm looking to be partial credit for getting the right answer, but again, most of the calculators, the ones I let you use, then it just gives you the answer. So I can't have that. I can't have, I mean, if you just put in a calculator, I wouldn't go over this. I tell you to put in your calculator, I move on. So I need to see that middle step. I need to see that square root of 4 and square root of 6. Now, some of you guys are smart enough where you can put in your calculator, and either one, you can help that can help you kind of have some guidance on what numbers you're picking. Or a second option, some of you guys are smart enough, you can put in your calculator and use that to work backwards to get this work right here. That's fine. If you can do that, then that's good enough. Honestly, you're not, I mean, I don't want to be this person necessarily, but I do want to be honest with you guys, you're never going to use this. And I wish if it wasn't a standard, I'd never use this. So the reason we're doing this is to more just develop some of that problem solving skills in your thinking about things a little bit differently. So if you can get the answer and work backwards to get that highlighted part, you know, I mean, you're doing some math processing skills. That's pretty good. I'm okay with that. So now I should change number 5 because it bothers me how this one works out and I didn't notice it, but that's okay. It still works. Number 5, you do it the same way. So 60 is right in here between 49 and 64. So take your 60, and again, you're just going to do trial and error until you find one of these numbers over here that works out nice and evenly. So 60 divided by 49 is a decimal. 60 divided by 36 is a decimal. 60 divided by 25 is a decimal. Almost, but still a decimal. 60 divided by 16 is a decimal. 60 divided by 9 is a decimal, and 60 divided by 4. So we had all those. We finally got to the one. It took a little while, but 4 is our answer. So we have 4, 15, and again, square root of both of them. Now the bummer is that I didn't want to use one with 4 again. We just had one with 4, but that's okay. Again, the square root of 4 is a whole number. That's why one of the numbers had to be from our list over here. And it'll be 2 root 15. Again, no one should ever miss these because you could do them in your calculator.
Show like what number we find. That is not always.
Well, this number here.
Like
4 by 2, you're taking the square root of 4.
If you're working backwards.
I just have to see this step. So if you work backwards, whatever you want to do, as long as I can see, that's the main thing. That's the thing I'm looking for. If you don't have a calculator that does this work for you, I don't remember. I don't know if the two guys do it or not. But if you have a calculator that doesn't show your work for you, it's a little bit longer to check your work. But here's how you square root gives you a decimal. Square root of 60, hit enter. That gives me 7.745966692. Then put your answer 2 times the square root of 15. Put that in your same calculator. It will give you the same exact decimal. If it's not, then you did something wrong. Because those numbers should be identical. That's the whole idea. We're not changing any numbers. We're just simplifying things. It's the same concept as 6 over 8 is the same decimal as 3 over 4. That's the same kind of concept. So let's do the same thing with 147. 147 is right over here. Let me get my change of color. 147 is right here between 144 and 169. So again, we start 147 divided by 144. I would advise you, if you think one doesn't work, I would still try it. If you know it doesn't work, then you can skip it. You don't have to type it in your calculator. 121. For instance, obviously, 100 is not a factor. 100 goes into 200, 300, 400. You don't have to. So obviously that one's not. But again, if it's not obvious, I would definitely advise you to still try it. 81 doesn't work. 64, doesn't work. 49. There, 49 does. So we got to one that does work. So we end up with the square root and the square root of is 7. We can't combine it. I can't reduce that down at all. If you do it this way every time, that's how it's going to work out. If you don't do it this way, sometimes when you get your answer, this square root of 3, you can reduce it again. That's exactly how number 7 is. So don't write this down because I'm going to erase it and we're going to redo this one. But someone in my last class for number 7, they just did 180 is 9 times 20. And the square root of 9 is 3. So that's how they did this one. That's perfectly fine. That's awesome. You did 2 numbers that multiplied to be 180. One of them, the 9, is from our list, so it reduced down really nicely. The problem is that 20 still can reduce down. It's the same concept. I did this in my other class. If you have the fraction 6 over 12, if you reduce that down to 3 over 6, yeah, you reduced it, but you completely reduce it. And I need you to do it completely. So if you just pick 2 numbers that multiply to be 180, that works sometimes, but you still have to be aware that sometimes you'll have to factor out another time. And I can show you that in a second. But instead, if you do it the way I've been telling you, you won't have to worry about that. You always pick the biggest number. That's why I always start with the biggest number and work my way down, because that way you don't have to worry about getting ones you didn't quite reduce all the way. So 180 divided by 169 doesn't work. 180 divided by 144 doesn't work. 180 divided by 121. And this is the process that sometimes this takes a little while, but you cannot sit there and say this is hard. Not this, I mean, the concept, the whole thing is hard, but this step where you're just putting in your calculator, if you think that's hard, then your life is going to be not great. You're going to be into a big shock when you get out into working world. 180 divided by 64. 180 divided by 49. Feel like I missed one. 180 divided by 36. There we go, 36. So I tried a bunch of these. I tried 1, 2, 3, 4, 5, 6, 7, 8 of them until I finally got the 36. But again, it's just calculators, just typing. From my list, because that way that number is always the one that reduces. Which I should say, if you put this the opposite way, square root of 5 times 6 this way, that's fine. That's not necessarily how people use it, but that's okay. Just make sure if you do this way, you don't accidentally put that 6 under the square root as well, because then it is wrong. Then I will have to count you wrong. So if you put square root of 5 and 6, that's fine. But if you accidentally do square root of 5 and 6 where it's both under that square root sign, that's not right. So last thing before I have you guys do some on your own. Again, I do not recommend doing it this way, but if you were someone that did that instead, where you said it was the square root of 9 times the square root of 20, so you said that's 3 times the square root of 20, that's fine. You'll just have to square root, do the simplify your 20, which is okay. That's square root of 4 times the square root of 5. The square root of 4 is 2 root 5. So instead of 3 times the square root of 20, it's 3 times 2 root 5, which is 6 root 5, which is what we had. That's just a lot longer of a process. You had to do essentially two problems in one. You had to reduce twice in one problem, and that's a pain. That's way worse than just putting it in your calculator and typing it out. So go ahead and do these on your own. I will call on some of you guys. So if you're somebody that the other day when I called on, you said, I don't know how to do this one. You need to ask. That's the whole concept. But we're going to do these on our own, and I'll call on some of you guys for help, and then we'll move on. This is the hardest part of the lesson, though. Once you get this part of the lesson down, tomorrow's lesson is a little confusing with imaginary. Today's lesson is not. So once you get this down, the rest of this lesson hopefully is smooth sailing. So make sure you have those two answers. And again, I need to see this work. However you get it, if you find the answer on your calculator, then work backwards. I can live with that, but I need to see that work. Now, just an FYI, there are some problems. These are the worst ones, and I'll try not to do any. If I do this to you, I'll try not to use any that are too big, but there are some that cannot be reduced. And for square root of 10, it's not that big of a deal. So you'd go over with 10. 10 is in between 9 and 16. 10 divided by 9 doesn't work. 10 divided by 4 doesn't work. So you find out very quickly that the square root of 10, you can't reduce that at all. However, there are problems that are like the square root of 102, which can't be reduced at all. And you have to try a lot more of them. So I just want to make sure you know there are some problems that you can't reduce. I'll try to shy away from those. But it does sometimes happen. So the next lesson is imaginary numbers. However, I'm going to give you this intro, and I've actually already given you this intro back when we did quadratic formula. But I want to give you this little intro because imaginary numbers are very difficult. Or I should say, imaginary numbers are types of problems that if you really want to go into depth, it gets very difficult very quickly. Trigonometry is one of those, where honestly the sine, cosine, tangent stuff, it's not too bad, but if you really go in depth on trigonometry, it's the worst. It's very hard. So, yes, question? Yes. Yep, absolutely. If I told you to reduce that, the answer is just 10. If you have a negative number, we find the square root of negative, that's where the I comes in. Square root of negative 1 is what I is. I square root of negative 1. So, the square root of 25, when we reduce just like the other ones, two numbers that multiply a negative 25, it's always going to start with negative 1. Negative 1 is I. The square root of 25 is I. If you put that as your answer, that's fine. Personally, what people do is they have their whole number comes first, their imaginary number comes next, and then if they have another radical, that comes last. That's typically how they write it, but I don't care as long as you are being careful of what's inside your radical. For 5, honestly, 12i, I can live with that. These others I do need to see more. Just for your purposes, 44 ends up being I12, which again, I like to write as 12i. You don't have to write it that way. To go back to Ryan's question, so if it doesn't reduce, you just put square root of 10. This one, the square root of 10 doesn't reduce. It's negative 1 times square root of 10. The square root of 10 doesn't reduce at all, so it's just I square root of 10. And again, I know this is a little bit nitpicky, but I promise I won't count you off for this. If you don't have a whole number, if you have a radical, they usually put the I before that. If you put it after, that's fine, as long as it is not inside the square root. If it's inside, I can't give you points for that. So, any questions on that so far? Once you know that, that is the only difference. We literally are doing the same thing we just did. It's just that there's going to be an I in there. That's it. Yes, question. So that's common notation. I will not count you wrong if you do something different. But yes, normally speaking, so if you had, well, let's just do number 13. I can show you the answer. Normally it's the whole number, then the I, and then the radical. If you mess that up, that's not a battle I'm fighting. So number 13, we do it the same way as before. We reduce it to negative 1 and 54. And if you want to skip that, we'll talk about that in a second. That I can do. 54 is over here between 49 and 64. So we have is a decimal, that doesn't work. 54 divided by 36, almost. It's 1.5, still not there. 54 divided by 25 doesn't work. 54 divided by 16 doesn't work. 54 divided by 9. Okay, so 54 divided by 9 does work. Is 9. Don't forget, you don't have to write this down, but don't forget your negative 1. I'm going to write it down again so I don't forget. So the negative 1 is an I. The square root of 9 is 3. And the square root of 6 doesn't change. Again, if you leave that in between there. And that's where it's the whole number the imaginary, and the radical. But again, I do not care. I'm not going to be nitpicky about that. Not at all. Now, the other thing I'm not picky about, I do need to see this set to show your work. Say, I need to see the 9 and I need to see the I or the square root of 1 somewhere. It doesn't have to be in the same step, but I do need to see all those. However, if I were you, I would skip that blue step over there, and the way I would do it is I would start with, I know it's going to be -1, and then I'd break down 75 before I write down the next step. So 75 is down here. I think it's 25, but if you're not sure, you're going to have to check because, again, you don't want to miss this just because you were too lazy to type extra buttons. So 75 divided by 64 doesn't work. 75 of 49 doesn't work. Divided by 36 and divided by 25. So we know that one works. It is 25 times 3. Square root of -1 is I, square root of 25 is 5, and square root of 3 you can't change at all. Again, I like to write it this way, but you do not need to write it that way. So that's the reason I put that in here. I wanted to put that in here because I wanted to know what imaginary number is before we get on to some of the harder stuff in the next lesson. But show you that really it's not actually any more difficult than all the other problems we've got. Any questions on those? Okay, so go ahead, do number 15 and 16 on your own. I'll call on some of you guys to put answers in. When you're done, if you want to start your worksheet, that's fine, but keep in mind I might call on you, so you might have to come back and participate in this. So double check your answers with those. Make sure you're getting the right stuff. If you don't, please let me know. But again, I'm hoping this is one of those that I try not to do this, but this is one of those that if you do about 10 of these problems, it gets easier and easier because you keep getting in the routine. So that's why your worksheet, I know it's a little bit redundant, but your worksheet ends up being about 10 problems. I mean, I know some of you guys, if you do 3 problems, you probably understand that you're good, but some of you guys, it's going to take 50, so I guess we'll settle on 10. If you have any other questions, please let me know.